Lesson 1-7, Part 2. On your summary slide, you can answer the question, what did we learn yesterday? Or what did we learn in our previous lesson? Our learning target is I can evaluate an expression written in function notation. And then our essential question is, how do you evaluate an expression written in function notation? Remember that a function is a relationship, a special relationship, where every input leads to exactly one output. So every input value for X leads to just one output value for Y. This is a click and drag function, not a function. So you might want to use two colors if you're working from home and just color, like highlight in one color for a function and then another color if it's not a function. So I'm going to do that just because space-wise I don't really have all that much space. So I'll model that for you. So what you could do is go to your highlighter and then just highlight this entire function area. So if you run out of room, you can just color that color and then pick a different color for not a function. So I'm just going to go with yellow or blue. Okay, so I can click and drag some of them and get them to fit. So if it's a graph and it passes the vertical line test, it's a function. So this is a function. This is not a function. This is not a function, because if I do vertical lines, it's going to touch more than once. This one's also not a function. And this one is a function. And I think that's all for my graphs. Okay. Then I'm going to move to my ordered pairs. If it's a function with ordered pairs, each X value has to be different. So this is a function because these values are all different. This one's not a function because of the 5 right here, repeated. Okay, now I'm going to move to tables and do the same thing. I'm focusing on those domain values. So here, not a function. This one looks good though. This one is not a function right here because that input of -5 is giving me two different output values. So -5 is giving me 3 and also giving me 5. 6 is giving me 9 and 10. And then this table looks good. Each of these values are different. Like on this one, each one is different. Okay, now with the mapping. Remember with a mapping, what you're looking for is you're looking for each domain value to just have one ray leaving it like this. That's good. This one over here, not good. Because right here, the 4 has 2 rays leaving it. And then this one looks good. This one does not. Right there. So if you're highlighting at home, you would highlight blue on any of these. And then yellow over here. These are all functions. Okay. Next up, now we're working with function notation. So this is where we start with our function rule, and then we have to plug it in to the correct function and simplify. So here's my first function rule. First one says f of 2. So that means that I'm changing x into 2. Changing x into 2. And then we simplify it. 2 squared is 4. 4 times 4, 16. Like that. My next one says f of -4. So I'm just going to write my function rule again over here. And this time, we're replacing the x with -4. So -4 squared is 16. 4 times 16 is 64. So those first two went with the function rule for f. Now the bottom two, notice that these start with the letter G. So now I need to change and start using the rule g of x. So it's just a different function. It's got a different letter to represent a different function. So I'm just going to write it twice right now because I've got two problems to solve. So the first one, I'm evaluating g of -3. So x, we have to turn the x into a -3, turn the other x into a -3, just like that. So it's substitution. 2 times -3 is -6, plus 7, 1. And then the last one for this slide, I'm replacing the x with 5 because it says g of 5. So replace them both with 5. 2 times 5 is 10, plus 7, 17. Okay, now depending on your comfort level, if you want to, you can try to do these on your own and pause the video. It's totally up to you. If you feel like they look different and you'd rather just follow along, that's totally fine. So what's happening on this next one is we're not replacing the x with just a number. We're replacing the x with m plus 5. So we're actually kind of complicating the problem a little bit more than it was originally. So what happens when you replace x with m plus 5 is the 3 that's out in front has to get distributed. So we've got to distribute here. So we will get 3 times m, or 3m, plus 3 times 5 is 15. I still have a plus 2 over here. So now I can put together the like terms, and the final answer is 3m plus 17. So that doesn't really look the greatest. It's kind of a complicated process because of what you're substituting in. Now the next one starts with the letter G, so I need to change to my rule with G. And on this one, we're replacing again with something that's more complicated. So you might not feel like you're actually simplifying anything. So we're replacing x with t minus 1, like that. Distribute. So that would give me 2t minus 2. 2 times 1 is 2. And then bring down the minus 1 and put together the like terms. So 2t minus 3 would be my final answer. Okay, now the third one looks different from the first two. What I want you to focus on here is this first, g of 0. So I'm going to figure out what g of 0 would be equal to. So if I replace x with 0, so x is turning into 0. 2 times 0 is 0. Minus 1 is -1. So what's happening here is g of 0 is -1. So this is like saying -1 minus 2. So that would equal -3. So simplifying on this one actually gave me a nice number. So this was not done. This was not completely done yet. So not done yet. Because of the way the problem looked, I had to go back over here and finish it. So take my g of 0 answer, which was -1, and then subtract 2 from it to get -3. All right, last slide, I think. Oh, and then a click and drag. Okay, so last slide of examples. So again, if you're feeling like you can try these on your own, just pause the video and try it, okay? So first one uses this rule. Nope, it does not. I'm gonna move that over, sorry about that. First one uses G of 8. So G of X equals 3X plus 4. And we're plugging in 8 because it says G of 8. So 3 times 8, 24, plus 4, 28. Then I'm going to go over here because this was 28 and I've got the minus 3 after it, so it actually equals 25. All right, now, there we go. The second one, we're substituting a negative m. So if I substitute negative m, like this, when I simplify this one, negative m squared means negative m times negative m, which is like negative 1m times negative 1m. Negative 1 times negative 1 is 1, and m times m is m squared. So this is really 1m squared, or just m squared. I know that was a lot of explaining for that piece. So when you square negative m times another negative m is actually positive m squared. And then I'd have the minus 5 from here. Okay, so m squared minus 5. That's my final answer. So not the prettiest answer. And then the last one says f of negative 5c. Okay. Move this? No. Okay, f of negative 5c. So my f of x rule, and we're replacing the x with negative 5c. Okay, so negative 5c for each of my x's. So negative 5c, so thinking about the process I used over here, if you multiply negative 5c times another negative 5c, you will actually get positive 25c squared, and then the minus 5. So here is final answer. All right, the last slide is a click and drag. Find the answer and click and drag it. You can draw a line if you want to, or highlight in some way. It's totally up to you. See if I can just fit it in a little bit better. There we go. Okay, so the first one, if I plug in negative 2, f of negative 2, so I'm turning this into a negative 2, negative 2 squared is 4, times 3 is 12, then plus 4, I get 16. Next, I have to plug in 8, so turn this into an 8. Negative 5 times 8 is negative 40, plus 2, negative 38. Next one, plug in 1 for x. 12 times 1 is 12. 8 minus 12, negative 4. Plug in 5. 5 squared is 25, minus 5 is 20. Plug in negative 15. Negative 15 plus 8 is negative 7. And then plug in 2. 2 to the third. 2 times 2 is 4, times 2 is 8, minus 4, 4. And that's it.